Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run survival analysis Kaplan Meier procedure in SPSS. The Kaplan Meier procedure, also known as a Kaplan Meier estimator, is a non parametric statistical method used to estimate the survival function from lifetime data. It is commonly employed in medical research and survival analysis to evaluate the time until the occurrence of an event such as death, disease reoccurrence, or failure of a treatment. Key features of Kaplan Meier procedure are survival function estimation. The Kaplan Meier procedure estimates the probability of surviving beyond certain time points. It produces a survival curve which shows the proportion of subjects surviving over time. Handling sensoring. It can handle censored data. I'll request all my viewers to kindly refer my previous video on survival analysis live tables to understand the concept of event and censored data. So it can handle censored data, which occurs when the event of interest has not yet occurred for some subjects by the end of the study, or when subjects drop out or are lost to follow-up. Censored data does not contribute to the estimate of the event probability beyond the censoring time, but is used to inform the estimation up to that point. So the Kaplan-Meier estimator for the survival function ST at time t is calculated by this formula, where Ti is the time of the ith event, Di is the number of events at time t, and I is the number of subjects at risk just before time Ti. Steps in Kaplan-Meier procedure are: imagine a study of 100 patients where each patient is monitored for up to 5 years for a specific event. Step 1, arrange the event times in ascending order. So you don't need to worry, software will take care of this. Step 2, calculate the survival probability at each event time. If 10 patients experience the event at 1 year and 90 were at risk just before this time, the survival probability at 1 year is 1 minus 10, the 10 patients, divided by 90. Continue this process for each subsequent event time and update the survival probability accordingly. Plot the survival curve, which shows how the probability of surviving decreases over time. Applications of Kaplan-Meier procedure. The Kaplan-Meier procedure is widely used in clinical trials to compare survival rates between different treatment groups. It helps in assessing the effectiveness of treatments, understanding the prognosis, and guiding clinical decisions based on survival probabilities. The Kaplan-Meier estimator is a fundamental tool in survival analysis that provides a clear graphical representation of survival data and accommodates censored observations effectively. So let's take a case study. A comprehensive study was conducted across multiple institutions to examine the factors influencing the survival time of cancer patients. The primary objective of this research was to identify significant predictors of survival outcomes and to develop a robust model that could assist in patient prognosis and clinical decision making. Key variables include the survival time of patient in days. So here is it, time. Censoring status, indicating whether the patient had died or was censored due to being lost to follow-up. So here is it. So status 1 is death and 2 is censored. That is the dropouts or still alive at the study's end. So the another possibility is the study ended and after that the event happened. So we are not aware about the status of the patient. So that is also censored. Specifically, the Eastern Cooperative Oncological Group ECOG performance score was used to assess patients' functional status ranging from asymptomatic 0, so here is it, PhD ECOG, to 4 bed bound. Additionally, the Karnofsky performance score, here is it, the physician Karnofsky score and the patient Karnofsky score, rated both by physicians and patients, provided a detailed assessment of the patient's overall health and ability to carry out daily activities, with scores ranging from 0, that is poor, daily activities, the patient is not able to do, 0 poor, to 100 good. Other variables included in the analysis were the number of calories, second last, consumed at meals, and the amount of weight lost in the last 6 months. Now let's see the data. The same data set, the data view. Let's see the coding. survival time in days, continuous, censoring status, 1 dead, 2 censored. So we are interested in 1 age in years, gender of the person, male, female, ECOG, there is 1 to 4, 1 symptomatic, 2 in bad less than 50% of days, 3 in bad more than 50% of days, bad bound. And this is Karnofsky score. Okay, now how to run Kaplan Meier? Go in analyze and analyze survival and Kaplan Meier. Now transfer survival time in time, censoring status in status, define event, single value 1. We are interested in we are interested to take the progress report of death, factor, gender. Now compare factor. So activate log rank, Bressler and Taranville. Click on options, activate survival and hazard. Continue and click OK. So we got the output. So this is the output which we got. Okay. Now here you will get the mean and medians for survival time, male and female separately, overall comparisons, the survival function, the hazard function. Okay, now let's start interpreting it. So we'll go in Kaplan Meier and here is it. So the first thing is the case processing summary. Total male 138, number of events which happened in male, death 26, censored 112, female 90, 37 number of events happened and censored 53. So what we'll write, out of 133 male respondents, 26 experienced the event of interest. So we always write event of interest. Okay, so the death or a failure, while 112 were censored, that did not experience the event by the end of the study or were lost to follow. The high percentage of censored cases, this one, suggests that a large proportion of males were either still surviving or not observed for the entire study period. Out of 90 female respondents, 37 experienced the event, 53 were censored. The percentage of censored cases is lower compared to males, indicating that a smaller proportions of females were censored. Now let's talk about this test. 3 tests are there. Null hypothesis, there is no difference in survival curve or survival distributions between males and females. See the p-value. So the p-value of log rank mental Cox is less than 0.05. This is more than 0.05 and this is less than 0.05. So significant results, the log rank, the first one, Taranville, the third, both indicate a significant difference in survival distributions between genders, suggesting that the gender affects survival times. Non-significant results, the Breslow test, this one, does not show significant difference at the 5% level, which means that while there might be some differences, they are not statistically significant according to this test. These results collectively suggest that there is a difference in survival times between genders, with log rank and Taranville tests providing more robust evidence of this difference. Now, see the mean survival time of male. So, mean and median. Female, mean and median. We'll write the interpretation. On average, males have survival time of approximately 719.2 units. At 95% confidence, that is that the true mean survival times for male lies between 622 and 816. This indicates that males on an average tend to survive longer compared to females. Median survival time. The median survival time for male is 840 units. Why we are writing units? So it can be days, years. So here it is days. So let's understand units as days only. This means that 50% of males have a survival time of 840 units or less, and 50% have a survival time greater than 840. So this is the mean for male, median for male. So 840 is here. Now let's do the interpretation for females. Mean survival time. So 535 and 529 on average, females have a survival time of approximately 535 units. At 95% confidence, that is a true mean survival time for females lies between 445, 455, here is it, 455 and 616. This suggests that on an average, females have a shorter survival time compared to males. Median survival time. The median survival time for female is 529. This indicates that the 50% of the females have a survival time of 529 units, that is 529 days, and 50% have a survival time greater than 529 days. So the survival function, male blue color, female red color. Wherever you get this plus sign, I'll request all my viewers to kindly refer my video on survival analysis live tables, in which I have explained the concept of censored and event and the symbols. So here plus sign is there, so there are dropouts, and this is the hazard function for male and female. So the hazard in case of female is more than male. Moreover, the survival curve, it steeply drops in female in comparison to male. So males generally have a higher mean and median survival times compared to females, indicating the longer survival on average. The median survival times are close to the mean survival times for both genders, suggesting that the survival distributions are relatively symmetrical for both the groups. The confidence interval for both mean and median survival times provide a range within which the true values are likely to fall, reflecting the precision and variability of the estimates. So this was all about how to run survival analysis Kaplan Meier in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.